So today we're going to talk about summing up. So summation, we'll talk about the notation and some key formulas. So this is what it looks like when we talk about summation. So first of all, this symbol here, this is a little s in Greek. They do have a different version for the lowercase. We have here a j, it's a subscript, so a sub j. J goes from 1 to n. J is our counter variable, so it counts your different terms. Sometimes you'll hear it called a dummy variable. It doesn't have to be j. Typically, it's like an I, a j, maybe a k if you get extra counter things in there. And then a sub j is your general term. So what this means is we are going to sum up all of the a sub j's as j goes from 1 to n. So here's where we start, and at the top is where we end. So start here, end here. So when we write that, right, we'd have a sub 1 plus a sub 2 plus, right, all this little a sub n. Cool. So we'll just practice writing out the sums and then we'll find the result. And I've got a calculator here because I'm not sure my arithmetic's going to be great. So we're going to sum up from j equals 1 to 3, the terms 5j, right? So we just go through and let j be 1, 2, 3. So j counts, right, positive integers. So what this means is 5 times 1 plus 5 times 2 plus 5 times 3. So is that 5 plus 10 plus 15, 25, 30? Okay. So sum up 5j as j goes from 1 to 3. Okay, here's the next one. So now we're starting at 2 and going to 5. And the terms are, so right here's your a sub j. All of that is your a sub j. So we'll get 2 squared plus 3 times 2, right, for j equals 2. And then we do it for j equals 3. So 3 squared plus 3 times 3. And then j equals 4. 4 squared plus 3 times 4. J equals 3, j equals 4, and then we stop when we get to, plus j equals 5. So we get 5 squared plus 3 times 5. Okay, and then whatever that is. Oh my gosh, you guys are probably already doing the arithmetic. So I got what? 4 plus 6 plus 9 plus 9 plus 16 plus 12 plus 25 plus 15. Okay, whatever that is. So a couple of summation rules. Adding and subtracting, you can go term by term. So if you add a sub j's plus or minus b sub j's from 1 to n, right, then that's the same thing as doing them separately. I guess that was a j. J goes from 1 to n plus or minus your b sub j's as j goes from 1 to n. Okay, so you can go term by term, kind of like what we did up here with the j squared and the 3j. I would get the same result if I did the j squareds first and then the 3j's separately. Okay, I'll get the same result at the end. And then this one, so c is just a real number. So if you have a constant multiple of a term, then that constant multiple, right, like it does in so many things in math, gets to move out front. And we get the same result. Okay. So for instance, if we looked up here on our 5 times j here, we would have gotten the same answer if we moved the 5 out front, added up our j's from 1 to 3, and then multiplied that answer by 5. Awesome. So that is what it looks like when we get the terms, or we get the general term and we have to write out the sum. But now a good practice is we have this series, right, the addition written out, and we want to write it in the summation notation. So we need to know where to start, where to end, and what that general term is. Okay. So remember your counter variable. So I'll go ahead and keep using j's for this one. So we start at, you can start wherever. We'll start at 1 if we can, based on some formulas that we're going to get to here soon. So j goes from 1, and then we have 1, 2, 3, 4. We have 5 terms. So I'm going to start or stop at 5. And then we need some way to describe, right, how we go through these terms, right? So this first one, and if you're having trouble figuring out what that generic term is, sometimes it's helpful to write what the J value is under each of them so you can kind of see that relationship. Okay. Right, so of course, right, these are just the even numbers between 2 and 10. So one way you could write that would be 2 times J, right? So if J is 1, I get 2. If J is 2, I get 4, 3, 6, etc. These are not always unique. So sometimes there are, in fact, most times there is more than one way to write your summation notation. Okay, so why don't you try that next one? So again, you write the sigma. Maybe I'll use an I this time. And like I said, there is more than one way to write this. So if I want to start at 2 and end at 10, I can start at 2 and end at 10. And then my generic term would be, right, it's a 1 all the way across the top. And then my denominator is just I. So 1 over I. Exactly. So the other way you could have done that then is start at 1. Sorry, go to 9, and then your term would be 1 over I plus 1. That would work as well. Okay, so just some basics on doing summation notation. So now I'm going to show you a couple of formulas for calculating these so that we don't actually have to add them up. So if you were adding up from 1 to n, just a constant, so c again is a constant, then what that formula is just n times c. Okay. And I should have written that out. So this means, right, c plus c plus c plus c n times, right? So repeated addition is multiplication. So this one here, if we're adding up from 1 to n all of these j's, we'd get, right, 1 plus 2 plus 3 plus dot 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 plus n. Okay. And what that equals is n times n plus 1 all over 2. And just getting us set up for something that we're going to have to do later, the other way that looks is n squared over 2 plus n over 2. Okay. Summing up the j squareds from 1 to n, right? So again, 1 squared plus 2 squared plus 3 squared plus all those terms in the middle plus n squared. A formula for this is n times n plus 1 times 2n plus 1 all over 6. And if you multiply all of that out and simplify, that becomes n cubed over 3 plus n squared over 2 plus n over 6. Okay. And then the last one we have a formula for, j cubed, right? So 1 cubed plus 2 cubed plus dot 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 plus n cubed. Right, and you might see a pattern, right? If it starts a j squared, we get an n cubed. Here we have a j cubed, so right, we're expecting our final answer to have a n to the 4th. So this is going to be n squared times n plus 1 quantity squared all over 4. And again, if you do all of that algebra, you would get to n to the 4th over 4 plus n cubed over 2 plus n squared over 4. Okay, so let's use those formulas to find these three sums. So I'm summing up 3j squared from j equals 1 to 5. So again, right, this 5, that is our n value. So we can move the 3 out front. And now we're summing up just j squareds from 1 to 5. And the formula for j squared is 3 times n cubed over 3 plus n squared over 2 plus n over 6. But n, remember, is 5. So that's 3 times 5 cubed, right? So 125 over 3 plus 5 squared over 2 plus 5 over 6. Oh my gosh, and I am not at all going to do any arithmetic, so Let's see, 125 over 3. Yes, I know there's the button to make it look like a fraction, but I'm okay doing it this way, and then times that 3 out in front. So 165. And absolutely, you could find that exactly the same number if you just wrote out the 5 terms. But, right, we're practicing using our formulas. Okay, next ones. So from 1 to 7. So I'm going to, right, I'm using all of those rules. So I'm going to break it apart first, right? So I'm going to add up 2 from 1 to 7. And then 4j from 1 to 7. Okay, so that first one, right, 2 from 1 to 7, so that's just 2 times 7. And now we're on to this one, so that's 4 times, so my n is a 7, and we're adding up j's, so that's going to be n squared, so 7 squared over 2 plus 7 over 2. Okay, so I got 14 plus 4 times 49 halves plus 7 halves. Remember your order of operations, and I'm grabbing a calculator, so 49 divided by 2 plus 7 divided by 2 times 4 plus 14, so 126. Great, last one. And if you want to pause and just see if you can get the answer by yourself, you can meet me at the end. Here I go. Oh, I have to use the same variable, so those will be j's, I guess. J equals 1 to 10 of my j squareds minus j equals 1 to 10 of my j's. So j squared is, so again, n is 10. So I'm going to get j squared, so what is n cubed? 10 cubed over 3 plus 10 squared over 2 plus 10 over 6. Minus, and it's going to be more than one thing, so I'll use my parentheses. And what do I have there? 10 squared over 2 plus 10 over 2. Okay. And then again, I'll grab my calculator because I am that kind of person. Plus 5. I know some of the arithmetic I'll do and some I won't. So it looks like that sum is 330. And I know some of you are going to want to check, and that is awesome. So you can go ahead and just add up those terms and make sure, right, just do it longhand, brute force, and make sure we get to the same place.